All right, so think about this. In super-regulated spaces like life sciences, the ones that follow GxP standards, every single thing has to be explainable. So what happens when you drop AI into the mix, a technology that by its very nature is probabilistic? How on earth to investigate an incident when you can't just replay the tape and see what happened? Well, that is the huge challenge we are going to unpack today. Let's get right into it.
Here's our roadmap. We're going to start by really nailing down the core problem AI creates for GxP. Then, we'll shift gears to a new goal for investigations called reconstruction and talk about the kind of evidence you need for it. From there, we'll get into the tricky part, how to handle these probabilistic systems, what that means for root cause analysis, and we'll wrap up with what is maybe the most important takeaway of all, that being ready for this stuff has to be a choice you make from day one.
Okay, Section 1, the GxP AI Investigation Gap. Before we can even begin to talk about solutions, we have to get super precise about the problem itself. Why is it that AI kind of breaks the traditional investigation models we've been relying on for decades? This right here, this quote sets the standard for GxP. And wow, it is a high bar. See, it's not enough for a system to just work. You have to be able to prove how it worked and why it worked. In this world, being able to explain, reconstruct, and fix an incident isn't just a nice-to-have. It is literally everything.
So what are we even looking for when we talk about an AI incident? It's not always some big, catastrophic failure. No, it can be any unexpected behavior, like an incorrect recommendation, a missed alert, or even just a slow, subtle drift in performance over time. The key is that it touches a regulated outcome. And the real danger is that these things often start out really small before they become a massive problem.
So this brings us right to Section 2, where we're going to pivot from the problem to the solution. When you're faced with a system that's probabilistic, the very first thing you have to do is redefine what a successful investigation even looks like. And here is the absolute crucial point. We are not trying to get the AI to spit out the exact same output a second time. A lot of the time, that's just plain impossible. Instead, our goal is reconstruction, to build a complete evidence-based picture of exactly what happened and why it happened.
And to actually achieve that reconstruction, an investigator needs to be able to definitively answer these 5 questions. What data went in? What was the whole context? What was the exact configuration at that moment? What came out the other side? And critically, what decisions did people make based on that output? If you can't answer all of these, your investigation has already failed.
This diagram just illustrates it perfectly. This is the kind of system that makes reconstruction possible. You can see there are 3 clear layers. You've got the control plane for all the rules and governance, the execution plane where the AI does its thing, and then, at the very bottom, the foundational evidence plane. Success here isn't an accident. It is the direct result of designing the system this way on purpose. And that foundational layer brings us right to the pillars of any investigation, the evidence itself. Because without the right data, reconstruction is just a fancy word for guesswork.
Let's be crystal clear on this. This is the absolute, non-negotiable rule. In a regulated world, you cannot fill in the blanks with assumptions or, "I think this is what happened." If the evidence isn't there, the investigation grinds to a halt and the integrity of your whole system gets called into question.
And the evidence we're talking about has to be comprehensive. It covers everything from where the input data came from, to the exact state of the model, to the decisions made by the control plane, all the way to what happened in other systems down the line. It's a full-stack evidence trail.
So let's look at this diagram one more time. See that evidence and audit plane at the bottom? That's the architectural solution. It is designed from the ground up to capture everything we just talked about. All the audit logs, the evidence stores, the validation records. This plane becomes the system's undisputed source of truth.
But, it's not enough to just collect all this data. You have to be able to correlate it. That's why timing is everything. Every single piece of evidence needs a reliable, synchronized timestamp. Without that, trying to build an accurate sequence of events becomes a total nightmare, and your whole investigation just falls apart.
All right, this leads us to Section 4, where we're going to tackle the big elephant in the room, the whole probabilistic nature of AI. We've got our evidence, but how do we apply it to a system that doesn't necessarily behave the same way every time? This, folks, requires a complete shift in mindset away from how we think about traditional software. So, the old world of deterministic software, it gave us this expectation of an identical replay. You put the same thing in, you get the same thing out. With AI, that's just gone. The new assessment is all about confirming whether the system's behavior, whatever it was, stayed within predefined validated acceptance boundaries. The question isn't, did it do the exact same thing? It's, did it behave like an acceptable version of itself?
And this, right here, is the core principle. Variability is not the enemy. You can totally have a system that produces a range of outputs, and that's perfectly okay, as long as you can explain why that range is acceptable and prove that the system stayed within it. It's the unexplained behavior that is a massive GxP failure.
So, once you have a successful reconstruction and assessment, that leads us right into Section 5 and the classic GxP process, root cause analysis, or RCA, and corrective and preventative actions, or CAPA. But guess what? Even these well-established processes have to adapt for AI.
You know, it is so tempting to just blame the model. Oh, the AI messed up, but that is almost never the full story. The real root cause is usually hiding in the system around the model. Was the input data garbage? Was the context put together incorrectly? Were the human checks and balances just not good enough? The investigation has to look at the entire ecosystem. And so it follows that the fixes, the CAPAs, they also have to be systemic. It's not just about retraining the AI, it's about tightening those acceptance boundaries we talked about, improving how you capture evidence, adjusting the approval gates, or maybe even completely rethinking the system's intended use. The focus is always on making the entire system more robust. And finally, we've arrived at Section 6, Readiness by Design. This is the most critical piece of the puzzle, the one that pulls everything we've talked about together. Now that we get the process, what does it actually mean for how we should be building these systems from the get-go?
First, a really important clarification. Understanding this framework is all about preparing your teams to conduct effective investigations. This is not, in and of itself, an authorization to deploy any system. And it doesn't define specific regulatory reporting requirements. Think of it as a methodological guide.
If you take only one thing away from our time together today, please let it be this. You cannot build an AI system and then, after the fact, try to figure out how you're going to investigate it. The ability to reconstruct an incident must be a core design requirement from day one, built right into the architecture, just like that evidence plan we saw in the diagram.
And that leaves us with the one question that I really want you to take back to your teams. It's not, can our AI be investigated? The question is it designed to be investigated? Because ultimately, the answer to that question is what will determine your success in any regulated environment.